Hey, welcome to Chapter 3. This is Mr. Hagel, and we're going to be looking at sections 3.1 and 3.2. Let's first take a look at some of the vocabulary words for this week. We have transversal lines, corresponding angles, alternate interior angles, alternate exterior angles, same-side interior angles, parallel and skew lines, exterior angle of a polygon, and parallel lines. And we will be going through the definition of these in this lesson. And we'll start with 3-1. Section 3-1 is lines and angles. Parallel lines. Parallel lines are lines that are coplanar and they do not intersect. Let's go ahead and put some points on this three-dimensional figure. So if we look at this figure now with some different points at the vertexes of the sides, we can look at the lines that go through these points. So first we can notice lines AB and lines CD. And to show that these lines are indeed parallel, or that we intend them to be parallel, we can use arrowheads, extra arrowheads on the lines. So our picture might look something like this. And we can then say that line AB, and we're talking about the line, is parallel to line DC. So notice this symbol right here, the two vertical lines, indicates or means the notation for parallel. Then we have two lines that are not parallel and they do not intersect. Those are called skew lines. So now if we look at line AB, and if we look at this figure as a three-dimensional figure, line AB and line DF will not intersect. So we can say that line AB is skew to line DF. So we can also talk about planes as being parallel. So let's go ahead and draw in our hidden lines here, and we can call that point in the back point H. So talking about parallel planes, we could look at, say, the top plane that has the points A, B, C, and D, and the bottom plane that has the points E, F, G, and H. So we can say that plane ABC, so that's going to represent the top of this box. So plane ABC is parallel to plane EFG. And notice when I name these planes, I only used 3 letters, although there are 4 that I could have used. It does not matter which 3 you use, as long as you use 3 and only 3 from any plane. EFG. So I could have called. So for this example, we have several questions referring to the picture here. And on this picture, we can go ahead and assume that things that look like right angles are right angles. And so we're just kind of getting a general sense of this figure right here. So the first question is, what's the relationship between segment, or we could say line BC, here's line BC, and line JF. So lines BC, this red line, and line JF, this purple line, if we were to think about this in 3 dimensions, you would see that these do not intersect. So the relationship is that BC and JF are skew lines. The next question asks about lines DF and BH. So let's look at those 2 lines. So lines BH and DF appear to be parallel. So we can go ahead and say that those 2 lines are parallel. And so we could even put the markings on them. So remember, the notation that we can use for lines DF and BH to say that they're parallel is we use 2 vertical lines This word here means parallel for our notation. Next question asks if planes BHG intersects with plane CDF. So BHG, those 3 points are going to define this surface here, and CDF is going to correspond with this front surface. So those 2 planes, if you look at them, those 2 planes are going to intersect at this line CG. So the answer is yes, they do intersect, and they intersect at line CG. So they intersect at line CG. Last question asks about planes ABD and plane IJF, if they intersect. Plane ABD is going to be this left side of our little house, and IJF is going to be this back side that's kind of hidden back here. And if you look at those 2 planes, they appear to be parallel. So do they intersect? And the answer is no. If 2 planes do not intersect, then they are parallel planes. And again, we could use our notation that says plane ABD is parallel to plane IJF. So the next vocab word we're going to talk about is the word transversal. And transversal simply means a line, this red line, that intersects 2 different lines or more, 2 or other lines. So these blue lines. So this red line is a transversal to the 2 blue lines. So with a transversal, our area is broken up into different regions. So we need to talk about those different regions. So we have interior. Interior is all the space in between our 2 blue lines. That's called the interior. So our exterior then is all the space outside of the blue lines. Okay, so that's all exterior. So the words interior and exterior deal with the 2 lines that are being cut by the transversal. So we have either between the 2 lines, which is the interior, or outside of the 2 lines, which is your exterior. Then we need to talk about the words alternate or same side. When we're talking about alternate and same side, we're referring to our transversal. And we're looking at the angles that are made with the transversal and our lines. So if we're looking at 2 angles that are alternate, alternate means opposite. So we have an angle on either side of our transversal. If we're talking about 2 angles that are same side, then they're both going to be on either the right side or the left side of our transversal. So let's put some angles in here so we can get a better look at this. So if we put some angle measures in here, like so, now we can talk about the different angles. For example, angles 1, 2, and 8 and 7 are all exterior angles because they are outside of our 2 lines, whereas angles 4, 3, 5, and 6 are interior angles. We could also look at angles 1, 4, 5, and 8. All of these angles are on the same side, and 2, 3, 6, and 7 are on the same side. But angles 2 and 1, they're both exterior, but they're on opposite sides, so we say alternate. So let's look at a few more of our definition terms, and we're talking about angle pairs. We have the word alternate interior angles. And alternate interior angles are going to refer to angles that are opposite sides, or alternate, opposite sides of the transversal, but interior of the 2 blue lines. So our alternate interior angles would be such like angle 4 and angle 6. They're on opposite sides of the transversal, alternate, but they're interior of our 2 lines. So 4 and 6 are alternate interior angles, and likewise 3 and 5 are alternate interior angles as well. Our next pair of angles are alternate exterior angles. And our alternate exterior angles are going to be opposite sides of the transversal again, so on opposite sides of the transversal, but this time they're going to be the exterior angles. So our exterior angles again are 1 and 2, 8 and 7. Next we want to talk about angles that are called same side interior angles or same side exterior angles. Same side interior angles are going to be angles that are on the same side of the transversal but interior of the blue lines. So we have angles 4 and 5 are same side interior angles, and so are angles 3 and 6. And we have same side exterior angles. Same side exterior angles are going to be, again, same side of the transversal, but on the exterior. So 1 and 8 are same side exterior, and angles 2 and angle 7 are same side exterior angles. The next pair of angles that we're going to talk about are what are called corresponding angles. Corresponding angles are these angles that, if you look at the blue lines, that are going to be on the same side of the transversal, but on above the blue line. So angle 1 and angle 5. Angle 1 and angle 5 are both above the blue lines and on the same side of the transversal. Likewise, angles 2 and 6 are corresponding angles, and angles 8 and 4. This time, angles 8 and 4 are both below the blue lines, but they're still on the same side of the transversal. So angles 8 and 4 are going to be corresponding angles. Likewise, 3 and 7 are corresponding angles. So when we have two lines in a transversal, we actually end up with 4 pairs of corresponding angles. So let's go ahead and list these 4 pair of corresponding angles. So we have angles 1 and 5, 1 and 5, angles 2 and 6, 2 and 6, 4 and 8, 4, 8, and angles 3 and 7. So we have 4 pairs of corresponding angles.